Probability as the measure of realization of chance. The concept of probability arose in logic as a means of defining lack of proof, but life has accumulated large numbers of facts that force us to consider probability as a problem in itself. This problem has been scientifically expressed in mathematics, in the theory of probability. Pascal evolved this theory as a means of understanding gambling in which the main role is played by chance. Today, probability relations are studied in the most diverse spheres of nature, society, and science. It is recognized that nature is governed by certain laws but lacks precision. Some scientists have suggested that probability may be taken to denote a subjective rather than an objective estimate by the knower. Others believe that this point of view cannot be accepted because the probability of a chance event is always independent of our reasoning about it. For example, our personal view of the chances that a ship will arrive safely exerts no influence on the actual outcome of its voyage. The theory of probability involves the study of mass phenomena. It can be applied only where large numbers of more or less equivalent factors take part. The classical theory of probability, derived from the study of chance in gambling, defines probability as the relation of the number of favorable outcomes to the total number of equally possible results. The future is not simply predetermined by what exists in the present. Objective possibilities of development may be divided into two groups: the necessary, those that must become reality, and the unnecessary, those that may not occur. A certain event is accidental if its outcome is only a probability and cannot be accurately predicted. If, on the other hand, there is a subjective factor, if people are taking part in bringing certain events about, the outcome is even more difficult, or strictly speaking, impossible to predict. Human actions are not universally predetermined. They are not programmed once and for all. Events whose occurrence cannot be determined with any degree of probability are called indefinite events. The life of nature is a kind of constant experiment, a kind of game or spinning of the coin, in which some probabilities become reality and others remain unrealized. Probability is a degree of possibility, the extent to which a given event may be realized in given conditions and under a given law. It characterizes the degree to which a certain possibility is grounded, the measure of its ability to become reality, the degree of its approximation to realization, the ratio of favorable and unfavorable factors. Probability is not simply the measure of our expectation, it is an objective measure of the possibility of chance becoming reality. Probability tells us how likely an event is to happen, what the objective grounds are for its happening, or whether it may happen at all. More probable means a more justified possibility. Probability is a property of sets of events. If we spin a coin only a few times or only once, it is impossible to say which side up it will land. Here we are in the power of chance, but this power is delegated, as it were, to the statistical law that when a large number of tosses are made, both possibilities occur with an equal degree of necessity. The coin is symmetrical, and this is the main cause of the equally probable result. If the probability of an event is very small, we ignore it. We sit at a lecture, for instance, without worrying about the possibility of being struck by a meteorite. Necessity is a 100% probability. The absence of any probability denotes the complete unlikeliness or impossibility of an event. The concept of impossibility reflects not only the fact that some possibilities do not exist, but also what processes do not allow the existence of these possibilities. Probability relations have two aspects: the internal, connected with the structure of the object in question, in our example, the symmetry of the coin, and external, connected with the frequency of the event, the number of tosses. The objective link between the internal and external aspects of probability is expressed in the law of large numbers, which states that the total effect of a large number of accidental facts leads in certain extremely general conditions to a result almost independent of chance. Every event is the resultant of necessary and accidental causes. The law of large numbers acts as the law of stable causes overcoming the influence of accidental factors. Constancy, stability appears within the limits of the conditions and causes that produce a certain phenomenon. In the example of spinning a coin, the main cause, symmetry of the coin, makes itself felt as the number of experiments increases. This cause operates continuously in one direction and finally leads to the realization of both possibilities. In a large number of experiments, the frequency of a number of chance events remains almost constant. This leads us to assume the existence of laws in phenomena occurrence that do not depend on the experimenter and that reveal themselves in an almost constant frequency. The stability with which some chance possibilities are realized in the mass captures our imagination, and in some people evokes a mystical feeling of fatal predestination and the inexorable power of numbers. The numbers of marriages, divorces, births, deaths, crimes, of passengers traveling by a certain means of transport over a certain period of time, the frequency of injuries in certain sports, mountain climbing, speedway racing, fencing, all exhibit a surprisingly stable regularity. For example, the number of children born out of wedlock runs at an average of 9% for the same number of people year after year. Decades of observation have yielded another curious law. During and after prolonged wars, the birth rate of male babies tends to increase. Statistical regularity, which exists objectively in a mass of individual phenomena, with its specific relationship between the necessary and the accidental, the individual and the general, the whole and its parts, cause and effect, possible and probable, constitutes the objective basis on which the massive structure of statistical research methods is erected. The methods of probability theory and the directly related statistical methods are becoming increasingly important in all fields of contemporary science. Statistical physics has developed out of classical physics, and probability principles have acquired fundamental significance in quantum mechanics. Information theory, the bedrock of cybernetics, is founded on the probability theory. Biologists, economists, sociologists and engineers are making ever wider use of probability methods. A special branch of logic, probability logic, has emerged and is being intensively developed. No matter how profound and comprehensive our knowledge, it cannot dispense with probability because of the unavoidable fact that probability in knowledge expresses a vital gradation between the possible and the real.